Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be on lesson 6.3. We're going to be talking about systems and matrices. Systems and matrices. This is going to be a action-packed lesson here, so make sure you pay attention. You might have to watch this 2 or 3 times because there's lots of moving parts here. So try to do your best, stay focused, stay engaged in the video. Best thing to do, take your pencil and start writing things down. Okay, if you work this out with me as we're going, I think it's going to help you a whole lot. All right, first thing I want to do, we're on page 286. I want you to look down there, page 286, and there's some key words there. One of the things is what's called a coefficient matrix. The coefficient matrix, and I've abbreviated it here on my screen. And then it talks about the constant matrix. And then we talk a little bit about the augmented matrix. Augmented. I wrote that out because that's the first time you've seen that word. You know what a coefficient is, and you know what a constant is, but you don't know what augmented means yet. So we're going to learn that today. Here's what we're going to do. You're going to love this part. This is the easy part of the lesson, okay? What you're going to do is you're going to take these elements, okay, of this row and this row and this row, and you're going to plug them into the coefficient and to the constant matrix. All right, so let's do that. What we're doing is we're really eliminating the letter. We're just taking the letter out, okay? A little bit later, we're going to show you how to put the letter back in at the end, but we want to take the letter out. It's going to be less confusing for us. So we're going to have a 3, a 1. You say there's no 1 there. Yes, there is. There's always a 1 in front of the y. And then a -2. The next one, oh, and then we want to put the 1. We're going to put the 1 over in the constant matrix. So there's two different matrices going on here. Okay, and this is important, not just in this lesson, but in future lessons, that you put them in the right place. So just the coefficient matrix and then the constant matrix. There's two separate matrices here. All right, the next row is 2, 3, 5, 4. The next row is 2, 1, -4, -6. And right now you're looking at page 286 and you're like, those are not the same numbers that I'm seeing on that page. You're right. I didn't use the same example that they're using in the book. I'm using my using an example that we're going to look at a little bit later. But the principle is the same. Take these elements and plug them into the coefficient and the constant matrix. Now, the next thing that we want to do is we want to plug all of these numbers here into what's called the augmented matrix. Now, let's look at the augmented matrix. This side is the coefficient side, and this side is the constant side. Now we're basically taking them from two separate into one. And you might say, why did we do that? Why not just put them right from here down into these spots? You could, all right? The reason I wanted to show you to do it like this is because we're going to use this later on in the chapter. You need to know how to do this, all right, to put them into those two spots. Now, if you want to skip that for right now, you can, but you need to know what the coefficient side is and what the constant side is. Notice this little bar right here. This little bar right here is something we haven't seen yet in a matrix. This is what makes it augmented. That's how we know that it's augmented. What does that mean? Here's what it means. It means that we have three elements here. The augment means to add something. When you augment something, you're adding to it. And then the augmented is the constant. Okay, so we're basically taking these elements and combining them into one. So let's go ahead and do that. All right, so we have 3, 1, -2, and then the augmented part is 1. And we're going to do that with all of those rows. 2, 3, 5, augmented part is 4. 2, 1, -4, negative 6. Okay, so what we've done here, and you can look, we have taken these elements right here, these numbers, and we've moved them down into the augmented matrix. Okay, 1, 3, 1, 1, 3, 1. Negative 2, 5, negative 4, negative 2, 5, negative 4. All right, constants 1, 4, negative 6, 1, 4, negative 6. Okay, so basically we've just taken the information and we've moved it down into the augmented matrix. Okay, I told you that was the easy part. I told you you'd like that part. Okay, now some of you are like, that's all I have to do? Okay, I can do that. Next. No, 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 no. That's not all we have to do. All right, so there's more. Take a look down here. I'm going to show you some things. I want to show you this guy right here. Carl Frederick Goss. Who is Carl Frederick Goss? Well, he's an interesting character. He's a mathematician, German mathematician. Maybe you could tell by his name. That's kind of a German name there. And what he did was he used EROs. What are EROs? Okay, that was last lesson, last chapter. What we learned in EROs last chapter was their elementary row operations. Elementary row operations. And what is that? Well, if you skip down here, I kind of go over what are the elementary row operations. The first one is switch two rows. Okay, so you switch 1 and 2. You switch 1 and 3. You switch 2 and 3. You switch two rows. Does it matter which rows? It's going to here, but it doesn't really matter in ERO. But when we're solving the matrix, it does matter. All right, step number 2, ERO 2. Multiply by a constant. Remember, we're trying to cancel. We're trying to get it to go to 0. You remember that from elimination, right? We're trying to get one of the elements to 0. We're trying to eliminate the x term. Okay, and we do that by multiplying by a constant. ERO 3, add rows to make, not add rows, but add the rows. I should probably have put in there. Add the rows to make a new row with the canceled variable. And so these are all things that we practiced in last lesson. But what this guy did is he combined EROs and matrices and to be able to solve systems of equations. So we're going to put those two things together. All right, so what we want to do now that we have this into our augmented matrix is we want to start solving this. We want to, in other words, we're trying to solve this system of equations. Now, we know how to do that, but what we learned before was it's a pretty long process. I don't know if you remember that, but it took like a whole page to do that process. This is going to take a while too, but what we've done is we've eliminated the letters, so it's going to become just a little bit easier. You'll see what I mean in just a second. All right, so let's skip down here and let's look at the steps to Gaussian elimination. In your book, this is on page 289, I'm pretty sure, 289, yep. So go ahead and go to page 289 and you can kind of follow along in your book. Now, my steps are going to be a little bit more simplified than the book steps. I try to simplify my stuff as much as possible so that you don't get confused on that. So, all right, number 1. We are going to write the system as an augmented matrix. Write the system as an augmented matrix. Well, good news. We already did that. When did we do that, Miss J? No, you remember. Okay, so we took our system. That's this little group of numbers and letters right here, and we took that and we wrote it into an augmented matrix. That's this matrix right here. Okay, so we have step number 1 done. We already wrote it in augmented matrix. Yay, we got 1 step done. All right, there's more steps than that. There's a lot of steps to this. 8 steps. I've got 8 steps for you. The book only has 7 steps, so you might like the book better because it's 1 less step. But I put an extra step in here that'll hopefully help you with this process a little bit better. All right, number 2. Combine row 1 with another row to make the first element a 1. Whoa, what? Combine row 1 with another row to make the first element a 1. Okay, here's what we want. We want this element right here to be a 1. That's what we want. That's what we're going for. Now, in this case, we can't just combine it with anything because, look, if we try to combine these two, that becomes the first one becomes a 5. So what we can do is we can take and we can multiply a negative through this. So what we're going to get is we're going to get 3, 1, -2, 1. Okay. And then when we multiply our negative through here, we have to distribute basically. So it's going to be -2, -3, -5, -4. And if you're wondering where this example is, because you're like, I want to follow along, it's on page 289 where the Gaussian elimination steps are. It's on page 289. It's on page 290. And I think it even spills over onto page 291. So it's lots of different things going on there. All right, so we're going to multiply this negative through. So here we go. That is on the top of page 290. Now what we're going to do is we're going to combine these for a new row number 1. Okay, this is going to be our new row 1. So what are we going to get? Well, just combine your different things. Remember, that's the augmented part over there, but that line is kind of important. All right, so 3 minus 2, that's our 1. That's what we were going for. That's what step number 2 says. Step number 2 says we need to make that element a 1. We need to make that element a 1, okay? So then we would combine this one, and this is going to give us a -2. We'll combine this one, and that will give us a -7. We'll combine the constant row here, and that will give us a -3. All right, now this is my new row 1. That's my new row 1 of my matrix. Okay, so let's rewrite our matrix using that for row 1. And I'm just going to come up here because I'm just going to replace this row number 1. I'm just going to erase all these that are in row number 1, and I want to put my new row number 1. Why am I putting my new row number 1? Because it has 1 in the first spot. So I'm going to replace it. I'll put it in yellow. I have 1, -2, -7, -3. Okay, so that's my new row 1. How did I get my new row 1? Well, I took my row 1 and my row 2 and I combined them to give me a 1 in the first spot. Remember, I had to multiply that negative through my row 2 in order to make that happen. You may have to multiply it by something too in order to get it to go to 1. But the thing that you have to focus on there is I have to get row number 1, the first element, to a 1. You don't have to worry about any of the other elements. Just element number 1. We need to get that to a 1. That's vital. Okay? All right, so here's my new augmented matrix with my new row number 1. All right, the next thing that I want to do is I want to go down and I want to go to step number 2, or excuse me, step number 3. I want to use row number 1 to cancel the first element in row number 2 and row number 3. So if you remember in elimination, the one thing I wanted to do is I wanted to eliminate my x. So I want to take this right here. This would be 1 and 2. And then I also want to take this right here, 1 and 3, okay? And I want to take those and I want to eliminate, what do I want to eliminate? I want to eliminate these cells right here, these elements right here. I want to get rid of those 2's. I want those to be zeros. In other words, I want to cancel those out. Okay. Why do I want to cancel those out? Because we are doing an elimination. Remember, it's Gaussian elimination. We are trying to solve we're trying to solve this thing is what we're trying to do. Okay. All right. So let's go ahead and do that. Let's do these ones right here. Okay. So I'll change the color so we can try to keep it 1, -2, -7, -3, 2, 3, 5, 4. Now you have to ask yourself, what do I need to multiply by to get that to cancel? And how about a -2? If I multiply that by a -2, this will cancel. That's what we're going for. Okay. So as we multiply that through by the -2, that's going to give us here, that's going to give us a -2. We multiply through here, we're going to get a +4. We multiply it through here, we're going to get a positive 14. We multiply it through here, we're going to get a positive 6. Okay? All right, so now what we want to do is we want to cancel that row. Okay? All right, so what does that mean? Here's what it means. We're going to take this, and that's going to cancel. Why? Because we have a negative 2 and a positive 2. So there's our 0. That was our key. That's what we were trying to do. Now right here, that's going to give us a 7 positive. Right here, that's going to give us a 19. And here, that's going to give us a 10. All right, so what is this? This is my new row 2. That's my new row 2. Actually, let me change that color so you can see it just a little bit better. I'll put it in yellow, row 2. Okay? All right, so here's our new row 1, and here's our new row 2. So now we need a new row 3. How are we going to get the new row 3? Well, the way that we get the new row 3 is the same way. We're going to take row number 1 and row number 3, and we're going to cancel those. So we have, and you can kind of watch in the book as it's doing it. I'll just do it down here to give more space. We have our row 1, which is 1, negative 2, negative 7, negative 3, and our row number 3, which was 2, 1, negative 4, negative 6. Okay, that's this row 3 right here. All right, so now I'm going to cancel those two rows. What am I going to do again? Notice I have a 2 here again, so I need to do the negative 2 through that thing again so that I can get a 0 right there. The goal is to cancel this out. That's what I'm trying to do. So I would get, and I'll change the color again here, so I get negative 2. I get positive 4. I would get positive 14, and I would get a positive 6. Okay. Now I want to go ahead and cancel. That's going to cancel. I'm going to add them basically. So 4 plus 1, that gives me a 5. 14 minus 4, that gives me a 10. And then 6 minus 6, that gives me a 0. That 0 is okay. Don't worry about that 0. Okay. All right. And so this is our new, and we could put a 0 here. This is our new row 3. So I'll put that row 3. All right. So notice what we have. We have a new row 1, a new row 2, and a new row 3. Let's go ahead and write that over here. We're going to put our new matrix right over here. Okay. So we'll put our row 1, and don't forget this is an augmented matrix. So we'll put that there. So what's row 1? It's right here. Row 1 is 1, negative 2, negative 7, negative 3. Row 2, it's right here. 0, 7, 19, 10. Row number 3, it's right here. 0, 5, 10, 0. Okay. All right. So now this is our new augmented matrix, but we're not quite done yet. Let's skip down here. In fact, we're a long ways from being done. So keep hanging on. I know this is going to be a long video, but we're going to get it done. Now, step number 4, use the new row 2 to cancel the second element in row 3. So in other words, here's what we want to do. We want to cancel this element right here, the second element in row 3. All right. So how do we do that? Well, we can use these two right here to accomplish that. If we multiply through, and this one becomes a little bit challenging at this point because the numbers are going to get a little bit big, but it's not too bad. If we put a negative 5 through there and a 7 through there, this is going to see we're going to get 0 here. We're going to get a negative 35 here. Sorry about that. 35. There we go. And we're going to get a positive 35 here. That's where those are going to cancel out. Okay? Negative 5 times 19 is 95. Negative 5, negative 95. Negative 5 times 10 is negative 50. Okay? And then now we're going to do the same thing. 7 times all that. 7 times, gives me 70. And 0. Okay? Because 7 times 0 is 0. All right, now what I want to do is I want to go ahead and add that, combine that, and we're going to get another new row here. That's going to cancel. This already canceled, so we have 0, 0. Okay, then we're going to combine this, and that's going to give us, what, a negative 25. And then this one's going to give us a negative 50. Okay? All right, now believe it or not, we are done. Almost. We're done with the Gaussian part. Now we have to do some back substitution and we're going to be done. So let's rewrite our matrix now. Let's rewrite our augmented matrix with, this is our new row 3. Okay? So this was our old row 3. We want to be done with that. So this is our row 2. Let's go back to our row 2. And we got rid of this row 3. Why? Because our step told us that we needed a 0 right there. And I'm going to show you why we need that 0 in just a second. So what I'm going to do right here is I'm just going to erase this one and I'm going to plug this back in. Because I don't want to take the extra time that it's going to take to do all that other stuff, basically. So we're going to have I'll write it in green, we're going to have a 0, a 0, a negative 25, and a negative 50. Okay, so I just wrote that new row 3 up there into the augmented matrix. All right, so believe it or not, we're done with that part. Notice what it says. Your new matrix should have a 1 in the row 1, 1, and a 0 in the row 21 and row 31 and row 32. So here's our rows. We have a 0 here, we have a 0 here, and a 0 here, and we have a 1 here. That's what it told us to do. We did what it told us to do, so we're good. Now what should I do? Okay, step number 5. Convert the matrix back to the original format with X, Y, Z, and K. K is your constant. All right, so in other words, we're taking this right here and we're converting it back into our X, Y, and Z. So I'm going to, and you know what, I'm just going to do this last one right here just to save a little bit of time. I'm going to do that one first because this is the one that we need to work with first. So if we have 0x, and go back to the original. It was 0x, we're doing this last one. So plus y minus z. Plus y plus 0y minus z. So minus, technically minus, we'll do minus 25z equals 50. That's our constant, negative 50. Sorry about that. In other words, all we're doing here is we're plugging in x, y, and z. And then that's our k. That's our constant. Okay? Now, notice what happens here. This stuff cancels. All we're left with is negative 25z equals negative 50. Okay? So let's go down and look what it says. It says, number 6, isolate z. What does that mean? Get z by itself. We need it to say z equals something. That's what we're going for. That's our goal. Negative 25, negative 25. This is amazing. Z equals 2. All of that work right there, all of those hours, it seems like hours, right? All of those minutes of working on this, and we got z equals 2. All right, now what? Okay, you can probably imagine what to do now. Now, step 7 is substitute the z back in. Okay, so we're going to take this z and we're going to substitute it back into this one. Okay, so 7y plus, I think that was 19. Where did it go? Yes, 19z equals 10. Okay, so now what we want to do is substitute that 2 back in for there. So we're going to have 7y plus 19 times 2 is 38 equals 10. So we substitute our 2 back in, multiply 2 times 19. And now we are going to subtract 38 from both sides. And that's going to give us 7y equals negative 28. Divide both sides by 7, and that's going to give us y equals 4, negative 4. Y equals negative 4. So we have our z equals 2, y equals negative 4, and now we're going to substitute back in one more time to this original one right here, and that will tell us what all of them are. Okay, so we'll go back here to the original equation, 3x plus y minus 2z equals 1. And we'll substitute back in here now that we have our y and our z. And so let's see, that will look like 3x plus y minus 2z equals 1. We said that the z equaled 2, so that's what we'll put in here. We'll put the 2 in there. And the y was negative 4, so we'll put that there. So it'll come out with 3x plus, well, negative 4 minus 4 minus 2 times 2 equals 1. So the z was 2 and the y was negative 4. All right, so there we go. Now let's just go ahead and solve this. Let's solve that right there. So we'll get 3x minus 4 minus 4 equals 1. Minus 4 minus 4, 3x minus 8 equals 1. Take the 8 over to the other side by adding 8 to both sides. 3x equals 9. Divide by 3 and divide by 3. We're going to get x equals 3. Woo, there it is. We got it. And so now let's write our answer in the standard form. So we'd write a parenthesis, x is 3, comma, y is negative 4, and the z is 2. And that is our solution using Gaussian elimination. It only took me 30 minutes to explain that. Well, just almost. So I know it was a long video. There's going to be things in there that you're like, your mind is going to be blown for a while. You might need to watch that another time or two. What I would suggest is do a problem, and when you're watching the video, do the problem along with it. Use your book and work on this Gaussian elimination. It's not easy, but it's also not too difficult once you kind of get the concept going. It's just kind of repeating the process. It's very easy to make simple mistakes, so be careful with your elimination. Be careful with your adding, subtracting of like terms. Be careful with all that substitution that's going on there. All those different things can add up and give you a wrong answer in there, so be careful with all that. Okay? All right, hope you learned something today. If you didn't, make sure you rewind that video, watch it again. All right, we'll see you later. Have a good one. Bye-bye.